I'd now like to give you your assignment for this week. What I want you to do is to find an engineered product in your home or in your garage or from a friend, something that's been designed by an engineer, and something that's hopefully not too simple, so preferably no knives or spoons or anything like that. If you want, it can be something that you can take apart, so you can look at the insides, you can take some photos if you want, you can include those in your work. And what I want you to do is to write a text of about 200 words describing this product. Now, I'll give you 5 suggestions for content points that you should put into this text. These are the shape, so describe the shape of the object, what does it look like, what are the geometries of the individual components, describe the materials, so what's it made from, describe the function, so what does it do, how does it work, how does it achieve this, describe the manufacturing, so how are these materials taken and shaped and finished, how are they converted from raw materials into usable components for the machine, and lastly, failure, what might go wrong. So what I'll do now, I've got this very old laboratory burner here, and I'm going to go through these 5 points with you to give you an idea of how it might be done. Obviously, I'm asking you to do this in written form rather than in spoken form, but I'll also give you a couple of written examples which I'll upload to StudIP. So, here we have a laboratory gas burner. This is a coal gas burner, so it doesn't use natural gas, it uses gas that's derived from coal, and it probably isn't quite as old as this university, but it might be getting close to being that old. I think it was probably made about 1890 to 1900. It's essentially a larger version of a Bunsen burner, which you may have used in a high school chemistry laboratory. And if we take a look at it, I'll begin with this pipe in the middle. Now, you may not know the difference between a pipe and a tube. It's also a bit of a loose difference in that sometimes engineers are in doubt as to whether something should be a pipe or a tube, and sometimes they contradict each other and disagree. But generally, a pipe is a long, hollow, cylindrical component which is intended to carry a liquid, a gas, a powder, something like that, some kind of loose material. A tube, on the other hand, is a structural element, so something which carries forces. For example, when the water comes into your house, the water enters your house in a pipe. Your bike frame, though, is made out of tubes. If I said to you that I had a bike and the frame was made of pipes, you'd probably think that, well, I built the bike out of some odds and ends of copper water pipe that I had at home. I built the frame myself and it was maybe an odd piece of art or a strange experiment. So, in the center here, vertically, we have this brass pipe, and at the top here, this expands. Now, with this kind of thing, I don't mind you being a bit creative. And the first time I saw this, I thought it looked like a sunflower, the head of a sunflower, and I would regard that as being a fair description, because everyone knows what a sunflower is. So you can describe this as being a sunflower-shaped burner. There's a similar thing that is a component of garden watering cans, and that also has a large ring of holes in the top of it. That's usually called a rose. Down at the bottom here, on this base, another example, you could say it's a trumpet-shaped base. That would be something that I would find fair. And you've got some other shapes here. You've got a a cube here where the pipe enters and then turns upwards at 90 degrees. Here you've got a hexagon, which is used so you can take a spanner and you can put the spanner onto this hexagon and use it to tighten the pieces together, because inside they have screw threads, and that's the way that the individual parts are joined together. Thinking about the materials, the tube here in the middle is made of brass, as are most of the parts. All of the yellow parts there are brass. Brass is an alloy of copper and tin. And there's a similar alloy, which is usually a little darker looking, called bronze, which is normally copper and tin. But these terms are, again, a pair of terms that are not used completely precisely. Brass is copper and zinc. Bronze is copper and tin, traditionally, but you'll find sometimes the bronze is made using silicon or aluminium instead of the tin, and some things that are described as brass, some things that are described as bronze are actually alloys of copper and zinc. So technically they ought to be brasses. One example is architectural bronze, which is often used on the outside of buildings. That's largely copper and zinc. You can see here at the side, this very narrow pipe is probably made almost of pure copper. The disc in the top here that has the burner holes, these are drilled into a plate of steel because that has to resist the heat of the burner when the burner is probably sitting under a water bath, something like that. So it needs a material with a high melting point. This is steel up at the top here. Down at the bottom here, the trumpet-shaped base is made of cast iron. Now, the difference between steel and iron is also one of those things that isn't precisely defined in engineering in English-speaking countries. Normally, cast iron, like this base is made from, has more carbon and more silicon than steel. So it might have 3 or 4% carbon and 1 or 2% silicon. And the steel that you see at the top here might only have 0.1 or 0.2% carbon and very little silicon. And normally iron is quite brittle, so it's formed by pouring it into a mold when it's molten. That's a casting process. In this case, it would have been a sand mold, and you can see the base is slightly concave because it shrunk a little into the mold. And steel, on the other hand, is more ductile, and after it's been cast, it can then be rolled into sheets or rails or girders, or it can be forged into things like spanners for tightening the hexagonal part here, or it can be pressed to make things like car bodies. And you can also see here there's some solder. Now this solder is older, it would be lead tin solder. These days you get solder which is lead free and it's mostly tin. And I think when it comes to materials, that's probably just about it, except there might be the remains of a little black paint there on the cast iron base. The function, what does it do? Well, the gas flows in here through a flexible hose, and this part here is known as the hose tail, which goes inside the hose, and it then turns upwards at 90 degrees inside this cube-shaped part. It passes through a valve, which has this fancy looking lever on here, which can be turned through 90 degrees. The valve consists of a cylinder, which is a very close fit in a cylindrical housing, and perpendicular to the axis of the cylinder, there's a hole, and by then turning the cylinder, you can align the hole in the rotating cylinder in the center with the housing, and that opens the valve, it lets the gas through, and it switches the burner on. The gas then flows upwards through a jet, which is a very small hole. This regulates the flow of gas, so you don't get too much gas, you don't get an uncontrollable fire. And also as it passes through the hole, the gas accelerates and the pressure falls because some of the pressure is used up in accelerating the gas. And this causes it to suck in air through these holes. And this is called the Venturi effect. And then this mixture of coal gas and air then flows upwards through the large brass pipe to the top, where it emerges from the small burner holes in the steel plate and it's ignited to heat a water bath or something like that. You can also use the valve here to regulate the gas flow. If you half close it, it'll reduce the heat generated by the burner. This here on the side, the copper and pipe, is for a pilot light. So pure gas comes up through here and it's just ignited at the top, and it'll keep the burner alight even when you close the main valve completely. So then you don't have to take your matches out to light it again. Manufacturing. What processes have been used to make this laboratory burner? As we've said, casting for the base. This tube here may have been rolled or extruded. It's a little hard to tell. Most of the other parts here have been machined as the final manufacturing step. So turned in the lathe to make a round shape, or placed on the table of a milling machine, and then the cutter moves over the top to make a flat surface. Probably the steel sheet in the top was rolled, and then holes were punched in the steel sheet. It was then crimped into the sunflower-shaped burner head. So the brass was then bent downwards to reduce the diameter of the top and hold the steel sheet in the top. And that's also a common process, crimping in electrical connections, so deforming something to give it a tight grip on another part, often a cable. And here you can see the copper pipe has been soldered into the brass base down at the bottom. Here you can see a small screw, which is for adjusting the pilot light. And this screw here might have been rolled. Given the age and the fact that it's brass, I think it's more likely that it was cut. A thread cutting tool for cutting a male thread is known as a die. And a thread cutting tool for cutting a female thread is known as a tap. Failure. What could go wrong? I can think of two things. Firstly, maybe if there is too little air in the flame, then the flame remains yellow. You've probably seen that. And partial combustion occurs, you get soot. This might block some of these holes in the top. The other thing that could go wrong is maybe the valve over time will become worn and it won't be such a tight fit. So the gas will be able to leak through the valve. Maybe the burner will continue to burn even after you've switched it off if it's very heavily worn, or maybe the gas will escape out into the atmosphere. What I'd like you to do for your assignment is pick an engineered product of your own choice and do something similar but in text form. I'll upload 2 texts about a light bulb. They are shorter than the text that I want you to write. I'd like you to write about 200 words, and I'd expect that that would take you at least 2 hours to do a good job of that. The light bulb text, there is one very bad text and one very good text with annotations which explain why they're bad and why they're good. And you'll find though that the bad text does not actually have any spelling mistakes or any grammatical errors that would be identified by software like Microsoft Word. I've done that deliberately because I want you to see that sometimes software can't tell that a text is bad. Your assignment should be handed in PDF format by email, and the deadline for handing it in is the 11th of May. If you have any questions, please let me know. Please send me an email. Thank you very much. That's all for today.